Okay. We're going to do some U substitution examples with our logarithmic rule. Log. Like 1 over x, the antiderivative is the natural log of x. Write this example down. We're not in the math joke mood today, that's fine.
I'm so confused. It's just like motivation. This is wow, Sean.
Okay.
Just not clicking for grace.
I still think.
And she's laughing. Okay, so sometimes our denominator may be the perfect candidate for our U substitution. Do you notice here how I have a fraction where the denominator is 1 degree higher than the numerator? Okay, that's a good sign, right? Why is that a good sign? If we let U equal the denominator, right, our derivative is always 1 less power, right, which is why that was a good sign. Okay, if we let the denominator equal x squared plus 1, then du would equal 2x dx. What do we have? We have x dx. That's fine. Move the 2 over. So this becomes, x dx becomes 1/2 du, and then we're left with x squared plus 1 as u. What should I put in my numerator? We gotta have something there, right? It's not 0, it's 1. Okay. Because if it was 0, then we would have nothing, and that would be sad. Okay, so now what is the antiderivative of 1 over u? The natural log of the absolute value of u. Did that not look like an L?
Well, there was just multiple lines. I got confused.
Is that better?
I like that.
Okay. Now, we have the absolute value here because we need whatever to be inside the logarithm positive. X squared plus 1. Is that going to be an issue? Is x squared plus 1 ever negative? No. So writing 1/2 the natural log of the absolute value of x squared plus 1 is fine, but x squared plus 1 is always going to be positive. So if you were to write it with regular parentheses, it wouldn't be a problem. It's like you kind of have a free pass on that one. The absolute value would not be necessary because x squared plus 1 is always positive. Yes.
Why did you put 1?
Well, x squared plus 1 turned into u, and that was in our denominator. We replaced the x dx with 1/2 du. And since I separated everything, I'm just going to put a 1 here because 1 times anything is itself, so it's a safe. I'm not changing the value at all. But we needed something up there. I don't want to leave it blank. Okay. All right. Other questions? Okay. Like I said yesterday, the more of these problems that you do, the better vision that you will have. Okay? Today we're kind of focusing on the vision of using that natural log rule. Okay, go ahead and write this one down. Okay.
It's motivating us to work harder.
Well, we started with zero motivation, so I'm glad that we're on the upswing.
It has been a little. We didn't have anything for fun. 0 to 1 is still a progression.
All right, so we have secant squared of x over tangent x dx. Do we have a rule for this? Just a straight up rule for secant squared over tangent? Now, we could use some trig identities to rearrange this to see if that could work. Could work. Or, what do you notice?
Sean's over here saying it's wrong.
Okay, tangent's derivative is secant squared x, right? Okay, so it feels like it's like destiny, right? That they're together, all right? If u is tangent of x, then du would be secant squared x dx. Okay, it's set up perfectly for us.
Is u always the denominator?
Yeah, how do we know that you use
So what Nicole pointed out is that secant squared is the derivative of tangent. So we knew that if we let u equal the tangent, its derivative secant squared is there for us. Okay? So kind of like I said,
Kind of got to play it by ear.
you have to play it by ear.
Finagle it a little bit.
I would say finagle. But like we have this vision, right? We know the process of u substitution and how we kind of need things to match up. And so you being able to recognize that tangent and secant squared are related that way would lead you to want to try to let u equal tangent of x. Does that make sense? So we have secant squared x dx. That gets replaced with du. I don't really like writing it this way.
Now it says
You tell your brother what happened in that class yesterday. Yeah, was he proud of you? Okay, so now 1 over u, its antiderivative is the natural log of u plus c.
For sure.
Sorry, I keep forgetting that. How much gum do you go through in a week?
I don't know. Not that much.
I feel like you're always like giving it out.
it's just a nice guy.
You guys want gum? So,
All right, so I'm going to put the next example on the board, and I want you and your pod to talk about how you think we're going to have to go about solving it. Okay? Obviously, it is not a straightforward rule. We're going to have to do something. So I want you to brainstorm what might be helpful in this case. Go.
Maybe this one is an expression.
like 1 over.
We go out on a limb here.
No, I think it's because it's like
We're taking the derivative of x. So we're taking the derivative of the natural log.
All right. Observations. Okay, Turner is saying that if we take the derivative of natural log of x, we get 1 over x. Do you see 1 over x in there? Yes, we do. I did see some people rewriting it like this to kind of help their eyes a little bit, and that's fine. Okay? If we let u equal the natural log of x, du ends up being 1 over x dx. Do we?
It's 1 over natural x.
That's okay.
No.
Because we have 1 over x dx, right? That's like the main issue we need to take care of. So 1 over x dx gets replaced with du. And then if the natural log of x turns to u, we have 1 over u. Which kind of seems awkward, right? That we replace the natural log and we still have 1 over u. Our answer is going to be funny. Okay, so the antiderivative is the natural log of the absolute value of u plus c. But u is natural log of x. Huh?
So these past 2 times, like the answer's just been a natural log of the denominator. Is that like my special thing? That we do a shortcut essentially.
This is the natural log of the natural log. It's still a natural log, correct?
What's your like?
Okay, Turner. What did you ask me?
So like these last 2 answers have been the natural log of u.
Yep.
So is that like a property or something that we'll learn?
No, not really. It's more of like the pattern that these have been set up to model, right? We've been letting the denominator equal u, and so when you have 1 over u, its antiderivative is natural log. It's just kind of the group of problems we've kind of been focusing on, I guess.
Does it get harder?
Of course. So.
Do we have an antiderivative for tangent? What is it? Okay. Oh, okay, we have an antiderivative for secant x tangent x. And we have an antiderivative for secant squared x, but we don't have this tangent, right? Let's figure out what it is. You ready?
There is one.
How could we rewrite tangent? Okay. So if we were going to use u substitution for this, which function would we have to let u equal?
No. Yeah. Cosine. Isn't it be
Why?
If you let u equal sine, the derivative would be cosine, and we technically have 1 over cosine.
Oh my.
Ah.
You see what I'm saying there?
That would not be helpful.
So if we let u equal cosine of x, du is negative sine of x dx. And do we have sine of x dx? We do. So this would become negative integral of 1 over u du. You don't have to memorize this, but you better know how to get there.
No, she was staring at me the whole time.
Well, you were looking at me, I was looking at you. How did everybody? Find the antiderivative of cotangent for me. Work together at your pod. I just modeled tangent.
You know it's not. Let's see, so this equals
Are you?
cosine of this. We still want to be using the water sign as our do.
Actually, I've done that.
So our
wanna
do
use
is
sine.
sine.
I would rewrite it.
Thanks,
But
sign.
even if we did
Alright, here's what I say.
We want sign.
Two of us split up, one of us, two of us send
We
you
have cosine.
as
Yeah, guys.
Sean has it figured out. U is
So you girls wearing the whole shirt at all tonight?
Yeah.
Did you get to pick your own colors or you have to buy the same?
No, we don't have colors. Why did the basketball team all has to wear like navy blue or something?
The girls that you guys pick their colors. Oh, is that the house? Yeah,
My wrong.
wouldn't you do just cosine? Sorry.
We stopped going.
I expect more from you. Aaron, what's the antiderivative?
Like with the antiderivative is cosine of x over sine. Oh, did you want like the answer?
I like the answer,
Oh.
the answer.
I had natural log of absolute value of sine of x plus
Makes sense that they're kind of related, right? You let u equal the sine of x and the same thing follows suit, except you don't have to worry about the negative. Okay? Two more examples. Can you bear with me here?
Yes, you can.
As I say that,
I would write this one down.
Oh.
Cancel the x.
All right, so what is kind of strange about this problem?
I can't see.
the
We gotta find a hole.
Ah, the denominator has a less power.
So we divide.
That's not really gonna help though. 2x squared plus 7x minus 3, like
Are we
that.
gonna have to?
Quick factor.
Yeah, cancel.
Well, you can try to factor 2x squared plus 7x minus 3, but I'm not sure if it'll go well for you. That would be an option though.
Alright, suggestion check.
If it factored nicely, we could do that if it canceled, but I don't think it will. We have an improper fraction. Do you agree? Our numerator's bigger? And what can we do with improper fractions? What did you say? We can divide. Yeah. Anthony didn't want to say
I said so.
Oh.
How was that improper?
it.
Asking you.
Well, good thing I'm here to help you with this one.
Yes.
It's improper because the numerator is larger.
Oh
This is algebra 2, repeated in a pre-calc.
It's long division.
It takes Would you rather me give you like
No.
an optimization problem?
Yes.
Yes? Okay. X times what is 2x squared?
2.
Okay. And then we take divisor times 2x.
2x.
And what do? We subtract. We subtract.
Add the opposite.
Oh.
Bring down the next value. X times what is 11x?
11.
And then we subtract again. We have a remainder of 19. So what we have, we did our improper fraction. Our quotient is 2x plus 11. But then we have a remainder of 19 that needs to be with the divisor. Doesn't this look much nicer? What's the antiderivative of 2x? X squared, right?
Friday.
What's the antiderivative of 11?
11x.
You're telling me this isn't nice?
It doesn't look nicer, but it's nicer for what we're doing.
I see. I should have asked that differently. Okay. Plus, this antiderivative is just 19 times the natural log of the absolute value of x minus 2.
So there's a shortcut. So, how do we know that it's?
Well, if the antiderivative of 1 over x is the natural log of x,
It's the same thing.
we throw an x minus 2 in there. Like, we don't have really any chain rule to worry about because the derivative is 1. We can go ahead and do that without your substitution. Okay. We have one more example, but questions before we go to that example. Okay, I think I'm going to have enough time to get through this example and then check your homework from yesterday. But since the pep rally schedule stole 5 minutes away and then the pep rally stole another 5 minutes, we don't get to do the quick activity at the end, but that's okay.
Was it a competitive one? 'Cause
It wasn't competitive, it was more like
I was-
be kind to a neighbor and help each other out.
Oh.
Wait, what?
Okay, you guys all complained about the dice thing and now you're
I
like wanting
like
it
that.
back.
I like the dice thing.
Okay, so I just heard a just loud complaints from a few people.
It was just very difficult, but I enjoyed the challenge.
That's good too.
Always.
It's always nice to have a challenge, right?
Hey, you played some tough D out there, Eli.
Thanks, man.
I was cheering for you the whole time.
You had some nice moves on offense too.
You just looked at it.
He just,
What was
as
the
we were
bet?
walking out, he said, I got $10 on Luke. I did not take that bet.
Okay. There are a couple different ways we can approach this problem. What do you think? What comes to mind for you? What'd you say? Okay, so I have one person, we can multiply all of this out and then multiply it by e to the x.
Dangerous.
Okay. And I have one person saying e to the x plus 1 could equal u. Yeah, and then du is e to the x dx. I don't know how much work you're saving, but a little bit. Do we have e to the x dx? Yep. So you'll notice that you'll notice that your assignment comes from 2 different pages, and I think it's like in chapter 5. Chapter 5 is just all about like exponentials and logarithmics, and so that's why you'll see those there. Keep your homework out. Remember, I'm going to come check it right now. So have it ready for me, unless you didn't do it.
Mine's halfway done.
Shoot. Wow.
Exactly half.